Hello. In this video, I will go over a dosage calculation relating to injectable medications. So let's do a few examples, and then we'll do more later on in the next video. So, yeah, injectable medication. So let's do example one. Um, we have an order of I can't really say this word, but enoxaparin, enoxaparin. Yeah, so we have an order of enoxaparin 40 mg subcutaneous injection once a daily. And our available is enoxaparin of 30 milligrams per 0.3 milliliters. So the question says, or one of the questions says, how many milliliters are created with each dose? Round to the nearest tenths. So we could do this part of the question in three ways: dimensional analysis, ratio and proportion, and I also believe we can also do the formula method. Okay, so the question says, how many milliliters, so our final answer has to be milliliters, are created with each dose, round to the nearest tenths. So we have an order of enoxaparin of 40 mg subcutaneous injections once daily, and our available is enoxaparin 30 milligrams per 0.3 milliliters. Okay, so let's start with dimensional analysis. So our final units has to be in milliliters. So the first thing I would do is I'm going to first start with order. You probably know this already, but just a little refresher. When we're dealing with a dimensional analysis method, we always start with what we have. So start with order, and then some always check if we have to do like a one or two step conversion. So this is where you got to check if you need to do any conversion. Okay, so we started out with 40 mg milligrams, right? 40 milligrams, and what we were given were 30 milligrams per 0.3 milliliters. So how are we going to set this up? Our final units has to be in milliliters. We were given our availability is 30 mg all over 0.3 milliliters. Should we leave it like this? No, we should not leave it like this because if we do, what happens is we will not have milliliters. We'll have our units will be off, right? So you can flip this. It's not changing the problem. You can flip this. You can say, you could put 0.3 milliliters and then 30 milligrams on the bottom. This is the same thing as this, right? This doesn't change that conversion. The reason why I'm going to put that is because I got to put milligrams at the bottom. If you recall, when you're multiplying fractions, uh, you multiply across and you want that milligrams gone and you want milliliters on top. So what is the relationship between milliliters and milligrams? For 30 milligrams, you're going to need 0.3 milliliters. Okay. So when you do the work, the milligrams disappear and you're left with milliliters. So when you're multiplying fractions, you multiply across. So it's going to be 40 times 0.3 and then over 1 times 30. Okay. And when you do the algebra, 40 times 0.3 is 12. And then 1 times 30 is 30. And when you do the algebra, 12 over 30 is 0.4 milliliters. Okay. It says round to the nearest tenth. I got exactly 0.4, so I don't really have to round. 0.4 is the tenth place. So that is your final answer. Okay, now let's do the same problem using ratio and proportion method. So we can set it up like this, uh, fraction equal sign. And then what you could do is we have two units. We have milligrams and milliliters, right? So you could put milligrams on the top and milliliters on the bottom, or vice versa, milliliters on the top, milligrams on the bottom. Um, it doesn't matter as long as this right here is the same as this. So you would have to put milligrams top, milliliters on the bottom. So our availability was 30 milligrams per 0.3 milliliters, right? And we were given 40 milligrams, but we want to know how many milliliters, so that's our unknown. Okay, go ahead and cross multiply. So this is going to be 30x equals to 0.3 times 40, and then 0.3 times 40, and then you have this 30x. Uh, and then wait, you could divide by, yeah, divide both sides by 30, get x by itself, so you get x equals 0.3 times 40 all over 30. And when you do the algebra, you get 0.4 milliliters. Okay. And then the last method, yes, you can definitely still do formula method. Some of these problems you can. This one you can. So what is the formula method? It's basically desire over half times vehicle. Okay. So what is our desire? It was for we first remember when you do this, you have to make sure desire and half are in the same units. Yes, they are. So what was our desire? Our desire was 40 milligrams. We had exactly 30 milligrams times it by the vehicle, which was 0.3 milliliters. And when you put it all together, you get 0.4 milliliters. Okay, let's move on to example two. Great. Yeah, that's all of it. Yeah, let's move on to example two. Okay, example two says you have an order of 5,000 units of heparin subcutaneous injection Q8H, which means every 8 hours, and our available is heparin of 10,000 USP units per milliliters. Part A, because I think there's two parts, says how many milliliters are injected with each dose. So let me read the problem. Again, we have an order of 5,000 units of heparin, subcutaneous injection Q8H every 8 hours, and our available is heparin of 10,000 USP units per milliliters. How many milliliters are injected with each dose? So yes, we can do dimensional analysis. Um, yes, so let's start with dimensional analysis. So we start with what we were given. We started out with 5,000 units. So wait, our final unit has to be how many milliliters? Our final answer has to be milliliters. So can we do this with dimensional? I think we can because we start with 5,000 units times, and our available was for our availability was 10,000 units per milliliter. Now, do for or per 1 milliliter. For 1 milliliters, there were 10,000 units that was given. Now, do we leave it like that? No, we have to flip it, but this doesn't change it because why do I want to flip this? Because I want units on the bottom because I want the units gone and I want to save I want my final answer in milliliters. So what is, yeah, you can flip this. So this is really you can say 1 milliliters over 10,000 units. So for 1 milliliter, there is 10,000 units. One, two, three, four. Two, four, all over one. And then what happens is the units disappears and then you're left with milliliters. So just multiply across. So 1 times 5,000 is, and then on the bottom, it's 1 times one, two, three, four. And when you put it all together, you're going to get 0.5 milliliters. Okay, where's your answer? Okay, now we can also do the same problem using ratio and proportion. So let's do that. Let's see. We could put units on the top, milliliters on the bottom, units on the top, and milliliters on the bottom. So we were given for 1 milliliters, uh, or our availability was for 1 milliliter, there were 10,000 units. And then our availability, we were given 5,000 units, but we don't know how many milliliters. That's our unknown. And then you may cross multiply. So x times 10,000 is 1, 2, 3, 4. And then it's going to be 1 times 5,000. 1 times 5,000 is 5,000. Get rid of this 1,000 or this 10,000. You get 0.5 milliliters. Okay, let's solve this using the formula method. So it's desire over half times available. And you always want to make sure desire and have the same units. Yes, they do. They're all in units. So our desire was 5,000 units. And then our have was 10,000. Times it by vehicle, which is 1 milliliter. So that's going to be 5,000 under 10,000. One, two, three. You get uh that would be 0.5 milliliters. Okay, and then there's also a part B. So the last part of example two says, how many milliliters are injected per day? So you have to go back to the problem. It did say it was Q8H, which means every 3 hours. So how many milliliters are injected per day? So for we have to inject, so we have 0.5 milliliters because that's from the answer from part A. And we got it injected every 3 hours, so times it by three, you get 1.5 milliliters each day, or a total of 1.5 milliliters each day. Okay, so that was inj injectable medication and yeah. Yes, we'll stop here.